Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, honorable judges and dear audience. Let me introduce ourselves. I'm Salsabila Melian and this is my partner Dinda Dwi Pratiwirahayu. Today, we will present our research with the title Effect of Compaction Temperature and Lignin Addition on the Marshall Characteristic of Pan 6070 asphalt mixture. This research was made to find new ways to make better and more eco-friendly routes. We use lignin, which is a natural material from plants, as an additive in asphalt. We also test the best temperature during asphalt compaction. We hope this research can help the road construction industry in Indonesia. This research is supervised by Dr. Insinyur Fitri Dawati Soehardi, STMT. We will explain why this research is important. Let's look at the background. Road damage like crack and pothole is still common. This happens because of heavy traffic and low quality asphalt mix. Asphalt pen 6070 is as a load, but it cannot handle high temperature and heavy traffic well. So we need to modify asphalt using additive. This is a good solution. Lignin is a natural material from wood. It can make asphalt stronger and is eco-friendly. Compaction temperature is very important. Wrong temperature can reduce the quality of asphalt mix. The Marshall test help us check the mechanical properties of the modified mix. Continuing from the previous background, research objective to determine the effect of compaction temperature variant and lignin addition on the Marshall characteristic of Pan 6070 asphalt mixture. This research has several steps. First, we test coarse and fine aggregate. Second, we test asphalt properties. Third, we test lignin. Fourth, we find the best asphalt content. And last, we do the Marshall test. The coarse aggregate test show good result. All parameters meet Bina Marga 2080 standard. Absorption is to 0.92%, absorption is to 0.14%, and specific gravity is to 0.92. All results pass the requirement. For fine aggregate, the results are also good. Sand equivalent is 94.11%. Specific gravity is to 0.545, and absorption is to 0.292%. All parameters pass the test. The PAN 60/70 asphalt test show good result. Penetration is 65, specific gravity is 1.003, and softening point is 55 degrees Celsius. All parameters meet the standard. The lignin test show good quality. Acid insoluble lignin is 80.68% and acid soluble lignin is 8.78%. This lignin is good for asphalt mix. The aggregate mix has coarse aggregate 39%, 5 aggregate 54.5%, and filler is 6.5%. We use 6% asphalt content. This mix is designed to meet asphalt concrete working course standard and make good quality asphalt. We test for different temperature. At the 130 degrees Celsius, the stability is 2,290.8 kilograms. At 135 degrees, the stability is 1,959.15 kilograms. At 140 degrees, the stability is 2,098.46 kilograms. And at 145 degrees, we get the best stability of the 2,268.03 kilograms. Our temperature past the minimum requirement of 800 kilograms. We test to find the best asphalt content. The graph shows the relationship between asphalt content and Marshall parameters. From this test, we found the best asphalt percentage for our mix. Now, for the next explanation, I will hand over to my colleague, Dinda Dwi Pratiwirahayu.
Thank you, Salsabila. Good afternoon, everyone. Now, let me present our result of the research using ANOVA now. Let's look at our ANOVA Statica analysis. We tested whether temperature variation significant affects the Marshall characteristic. We analyzed 7 parameters at 4 temperature 130 degrees Celsius, 135 degrees Celsius, 140 degrees Celsius, and 145 degrees Celsius. Next, let's look at density. Density represents the coefficient of the asphalt mixture, as you can see in this table. Temperature significant affects mixture density, Celsius 4.25. FMA represents the flow of fluid between aggregate particles in the compact mixture. Fluid in aggregate show even stroke if effects with fluid 6.81 hingga temperature increase fluid space. The trend parameter is FVA, fluid blend with asphalt. This respects the prospect of fluid in the mineral aggregate that are fluid with asphalt. Fluid with asphalt flow is 3.96 hingga temperature improve asphalt penetration. Fluid in total mix, this respects the total air fluid in the compaction asphalt mixture. Fluid in mixture fill was 3.96. Temperature significant influence total fluid content. Moving on to stability, one of the most important martial parameters stability response the mixtures resistance to deformation under load stability. The load bearing capacity 4.86 at 145 degrees Celsius. Next is flow. This parameter measures the plastic deformation of the mixture under load before fly load. Flow plastic deformation 3.95 at 145 degrees Celsius. Finally, the Marshall function. This is the most important feeding of our research. MK is clothed by dividing stability by flow, respecting the overall mixture stiffness. Okay, then leave it to Salsabila.
Thank you, Dinda Dwi Pratiwirahayu. Next, closing. Solution. Based on the study of the effect of compaction temperature variance and lignin addition on Marshall characteristic using a one-way ANOVA test, it can be concluded that compaction temperature ranging from 130 degrees Celsius to 145 degrees Celsius have a significant influence on all 7 Marshall parameters. Suggestion. 1. It is necessary to conduct Marshall characteristic testing with additional intervals of compaction temperature variance. 2. It is necessary to perform abrasion testing on the asphalt concrete wearing course asphalt mixture with the addition of lignin. That is our presentation. We hope this research can help develop better and eco-friendly road construction. Thank you for your attention. We are ready to answer your question.